Okay, honestly, I do believe this is my favorite question in this packet. Not that the tennis racket one wasn't engaging, but this one's pretty exciting, right? So curling is a game played on a horizontal ice surface, blah 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 blah. Right. So here they are. If you look at this part here, this is where they're speeding it up, right? So they're speeding it up, and then here is where it coasts, right? The stone moves until so here it's slowing down at a much slower rate, right? Um, and the first one is they say determine the maximum speed v of the stone. Well, you gotta love that, right? We've got the time here, right? And then they tell us that it's 17.5 seconds and it's 29.8 meters. Here's the key concept. The area underneath this has got to be 29.8. That is, if we go, the area under a velocity time graph is displacement. Okay, now you're going, well, so what? Area is displacement. Well, okay, so now we can set up equations. Like, so for example, use the height of the triangles to be v, right? So this first triangle here, its area is 1/2, the base is 3.5, and then v is the height, right? Okay, this triangle here, notice that if this is 3.5, that this distance is, or this graph distance is 14 seconds, right? Is over which it slows down, right? So set up another one. So plus 1/2, 14 is the base, and v is the height, right? Well, and these are seconds, and those are seconds, right? That has to equal 29.8 meters, right? So set up the area equation. I think that's a brilliant question, right? Okay, and then solve for what that v is. Okay, that v is somewhere between 3 and 4. Okay, I'll just say that. So then it says determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds of the stone's motion. Well, I think we need to find the deceleration of it, right? So v is u plus at, right? Our initial velocity will be what you figured out from here, right? Okay, the final velocity will be 0, right? Yep, it's 0. Okay, the time is going to be 14 seconds. Solve for a, right? So that's step 1, right? We've got 3 marks here, right? Okay, step 2, realize that while it's decelerating, mu times m times g is the friction force, and that equals m times a. Okay, so we don't know the mass of the stone, but we don't need to know it, right? So now plug that in. G is 9.81. A is the acceleration you just got, right? And you should arrive at a coefficient of friction. Remember, it's just a pure number. And it looks like we either have, I guess we have 2 sig figs, right? Because of the 3.5 here, okay? So happy hunting on that one. That one shouldn't be too bad, right? But it is a little tricky, right? I mean, this is just tricky. You might stare at that and go, gee, I just don't know how to do that. But there it is. It's a hard test. Okay, let's go to the next page here. Okay, and then this one kind of looks like looking at the mark scheme. I think candidates gave just such random, diverse answers that it looks like a poop storm. Okay, I'm sorry, that's a little bit strong language for YouTube here. Okay, but I took it to be label the diagram to show the forces acting on the stone. Your answer should include the name, direction, and point of application of each force. So I thought that the arrows should emanate from the point of contact, and you should label what they are, okay? Only I didn't label one of mine correctly, right? So I'm going to give you a clue. There are 3 forces. I'm just going to let you, just have at it. There are 3 forces, okay? Acting on this thing. Gravity would be one of them. The ice exerts a force on there, right? I didn't label that one correctly, and then there's going to be a frictional force. Okay, try to label them from the point of contact. Now, in some cases, the point of contact is like every particle in the thing is feeling this force, right? So I don't know what that means, right? Anyway, happy hunting. They want you to draw arrows, and they want you to draw them emanating from, like, for example, if I have this thing here and I've got my hand, if a tennis racket is hitting this, a biscuit or something like that, right? You would draw, if this thing's hitting that, you'd say, okay, the tennis racket's exerting a force that way. Notice that it's striking this surface and the arrow emanates from that. I don't want to give this away, so there you have it.